Okay, next question here. For two capacitors connected in series, as we kind of see here, what happens to the net capacitance? If C1 is fixed, we'll just say it's the 10, and C2 goes to infinity, right? C2 just becomes super, super big. Let's think. Oh, raise your hands if you think C net is unaffected. Raise your hand if you think C net is going to go to 0. Raise your hand if you think C net is going to infinity. Raise your hand if you think it's not enough information or something else, right? Okay, so let's figure it out. We'll do the algebra using our formula first, and then look at kind of what is happening here, kind of have a physical understanding, sciencey understanding of what's happening. So the algebra says that C net is 1 over C1 plus 1 over C2. Hush. Okay, right? That's what we're saying here. C1 is fixed and C2 goes to infinity. C2 just gets super big. It becomes a really big capacitor. So if this goes to infinity, that fraction is going to go to 0, right? We're going to say that C2 goes to infinity, which means we have 1 over C1 plus 1 over, I'm just going to write 1 over infinity, right? Just give us an understanding. 1 over infinity, like that's 1 over a huge number, is essentially 0. So we get 1 over C1 plus 0. There's a lot of 1 overs there. So I'll put C net equals 1 over C1 plus 0 equals 1 over C1 equals C1. Okay. We can see the work here, right? 1 over C1 plus 0, right? Because that goes to 0, which is just, okay, get rid of it. 1 over C1 is just C1. So C net goes to C1. So it's like if C2 gets, and vice versa, right? Whatever. If C2 gets huge, C net just equals C1. Maybe I'll put arrows. Right? As C2 goes to infinity, C net goes to just C1. And, okay, let's kind of look at why is that happens, okay? All right, I'll be done with that. So, if C2 is getting big, what's that kind of mean? It means that the plate, one option is those plates are getting really big. You know, it's like instead of a small plate, you know, a wire, a plate, a space, a plate, and then a wire, it's a bigger plate, and then a bigger plate, and then a huge plate. And what's happening here is the charges are moving along the wire, and in a normal capacitor, they kind of run out of room. You know, they get to the capacitor, they start filling it up, positive charges on this side, negative charges on this side, and then they fill up, and that filling up slows down the electrical current, right? It's like, oh, we've filled up the plates, the charges can't move anymore. If the plates are really big, the electrical current comes along, the positive charges come, and they distribute across the plates. But they have so much room to distribute, these positive charges just keep accumulating on one side, the negative charges just keep accumulating on the other side, which continues the current along this wire here, right? So it's kind of like all these charges build up here. They have so much room that they could just go indefinitely and it never impedes the electrical current. And so all that's left is just capacitor 1. That's one way of thinking about it. The other way is, where's that formula? It's right here. We go back to here, right? C is epsilon naught A over D. I was kind of thinking about it in terms of A. A gets really big, C gets really big. Here's another way. What if D, the distance between the capacitors, gets smaller? That's another way for the capacitor to get bigger, is if D gets smaller. Well, let's kind of just think about that. If the distance between those plates gets smaller and smaller, in the limit of C going to infinity, that's D going to 0. Essentially, those two plates are eventually going to touch, and it's essentially just an open wire, which is kind of like what we see here. Maybe there's some plates there, but it's just a conductor the whole way through, leaving us with just that C1 as the net capacitance. And so that's kind of what happens. Y, as C2 goes to infinity, the net capacitance goes to C1, or the other way around. Next, we'll look at what happens as, how about C2 goes to 0? We'll do the algebra and kind of figure it out.